If you are a software developer with non-traditional background, you already know how to write code to build things. But let's face it, there are moments in your career that you wish you had a deeper understanding of what's really going on under the hood. For example, when you are trying to fix a nasty bug, finding out the bottleneck of the system, or designing a robust architecture. There are a lot of resources online, but they either focus on learning how to code, which you already know, or they focus on going through all the courses of a computer science degree, which you don't really need to. What you really need is the core computer science fundamentals that you can learn so that you can be better at your job. The resources I'm going to talk about in this video is based on my research of many computer science curriculums and my learning experience as a software engineer over the years. It covers computer systems, operating systems, computer networking, data storage, and distributed systems. Let's get it started. First, let's look at computer systems. The first one is Crash Course Computer Science YouTube playlist. Even though this course is meant for general public, I still think it's a great starting point if you are a beginner when it comes to computer systems. Each video is about 10 minutes long, the videos are engaging, and it does cover the important bits of how a computer works. It's a great choice if you are seeking an easy to understand introduction to computer systems. The next one is the book Code, the Hidden Language of Computer Hardware and Software. This book is a classic intro of how computers work, and it has been recommended by many tech companies internally. First published 20 years ago, this book has stood the test of time. Unlike the ever-changing world of frameworks and libraries, we know how it is. The second edition, recently published, has more content and has some modifications based on the new age of computing. If you already have a basic understanding of how computers work, but crave a deeper understanding of the why and how, this book is a must-read. Countless readers, including myself, have found its knowledge presented in an accessible and easily understandable manner. If you are a hands-on type of learner, then this Coursera course is a great choice since it is project-oriented and it is a self-contained course. All the knowledge necessary to succeed in the course will be given as part of the learning experience. And what's interesting is that at the end of the course, you will get your own minimum version of computer system after working on all the assignments. While numerous open source university courses introduce coding and programming, finding ones that focus on computer systems can be a challenge. However, during my research, I stumbled upon this remarkable public course. What sets this course apart is the instructor's unique approach of teaching with pen and paper, which I personally find more engaging than slide presentations, and it covers the essentials deeper than previous resources. Note that to follow along the assignments, you will have to pick up some C programming. The next one is a CMU course. This course is a well-known classic computer system course. If you Google CSAPP, you will see many discussions around this book. This course seems to be publicly available at one point, but there are no official lecture recordings anymore, although you can still find unofficial ones on YouTube. This course has great quality, but be prepared to invest significant time into reading the materials and completing the labs, especially when you are already working full-time. Next, let's look at operating systems learning resources. The first course was taught as an undergrad course. The professor is also the author of a well-known book, Operating Systems 3 Easy Pieces. There are no slides used. The professor illustrates the concepts and the mechanisms using digital pen and paper throughout the lecture. While I find this teaching style more engaging, it may not suit everyone's preference. The next one is a free Udacity course that is also part of Georgia Tech's computer science degree curriculum. If you prefer lectures with slides and more concise content, I believe this course is a great alternative compared to the course earlier. In between videos, you will be prompted to answer some questions to check if you have grasped the concepts. After you get a good understanding of computer systems and operating systems, next we will take a look at resources to learn computer networking. If you consider yourself as a beginner on this topic, then this free Udacity course is a great start. For example, if you are a front-end engineer wants to learn what is happening behind the API request, or learn about the concepts other back-end engineers often talk about, I would recommend this course since it's beginner friendly. There is another similar free Coursera course from Google. It is also for beginners. The course duration is slightly longer than the previous one with more details. However, this course is slightly more geared toward people who want to become network engineers. As you can also see, it is part of Google's IT Support Professional Certificate. I would say there are not that much difference between those two courses. It depends on the depth you want to learn about computer networking. The next one is a course on computer networking. It is a classic course that is often seen in undergrad computer science curriculums. I really appreciate how the lecturers open source this course with videos and notes, and you can also use Wireshark Labs to get some hands-on experience with computer networking. I believe this is a great course to take to form a systematic understanding if you can commit the time. The next important piece is data storage. First recommendation is an open source CMU course on database systems. Yes, the professor recorded the first lecture in a bathtub. The first time I watched the video, I thought it was a prank. But don't worry, it is a legit CMU course and the professor is a fantastic teacher. The lecture goes over the design and implementation of disk-oriented database management systems with case studies on open source and commercial database systems. It does not include anything about database admin or how to use database to build applications or SQL queries. It is about database itself. Note that the course assumes you know how to write C++ to work on the assignments. Next one is the book Designing Data-Intensive Applications. This book has been recommended in many places by many people for a reason, and it is a really good book because it provides a pretty solid overview of data processing landscape in today's era. Last one is the Database Internals book. This book goes deeper into implementation details of data structures, algorithms, concepts that are essential in building a database, as well as distributed data storage. If you're interested in implementation details, it actually complements nicely with the Design Data-Intensive Application book we just saw. Note that there are some overlaps with the CMU database system course, so you can probably just pick one and stick with it to learn those details. Now comes to the last section, distributed systems. The first recommendation is an open source MIT course on distributed systems. This course covers classic distributed system concepts and products such as MapReduce, GFS, Zookeeper, Spanner, etc., with hands-on labs using Go programming language. I personally think it's better to take this course when you already have at least some ideas about distributed system, the benefits and challenges come with it, and have the expectation that these classic solutions took multiple people's research over months or years will require some time to grasp. If you're new to distributed system, I would suggest the Design Data-Intensive Application book I mentioned earlier as a start. Let's check the last learning resource. If you've done any tech interview in the past 5 years, most likely you've heard about this author or this book. There are 2 volumes of the System Design Interview series, but I particularly want to recommend the second volume since it has a wider and deeper coverage on distributed system design compared to the first volume. Even though it is interview-oriented, the reference in this book is rich enough for you to learn about all kinds of practical problems engineers have encountered, and it can also help you with system design interviews. If you enjoy the content of this video, click the subscribe button so you can receive more content like this in the future. Thank you.